Swayam Prabha, free DTH channel for education.
Hello everyone. So today we are going to talk about reduction of order and few problems on constant coefficient. Suppose the linear ODE with constant coefficient and some of the approaches like superposition approach and annihilator approaches, etc. We are going to see. So here what we are going to do is that so let's have a quick recap of what we did in the last class. So we have covered y double dash plus p of x plus y into y dash plus q of x into y equal to 0 was there. So this is the second order linear ODE problem is there. So for this problem, we have discussed some of the linearly independent solution. Two solutions are there, and linear combination is going to be a solution that is called superposition principle. And then we have discussed about the Ranskian and when p of x and q of x are continuous and initial value problems are there, and how the existence and uniqueness is going to be there. These are all the things we have seen so far. Now what we are going to do is that we are going to see reduction of order. So let's have a quick recap of what we did little bit. So this is the second order linear ODE. So if I put R of x here, R will become like a homogeneous. If R of x is not homogeneous, this is called non-homogeneous ODE. So in general, second order linear ODE is written in this form. Okay. Now what we are going to do is that suppose suppose you know one solution. Okay, suppose you know one solution. Y1 is known. So now what we are going to do is that we are going to use that reduction of order and then going to find the solution. Suppose your one solution is known to you, y2 equal to one solution is known to you, y1 is known to you. Okay, y1 is known to you. And y2 can be written something like y1. Suppose one solution is known. We are going to use this one to find the second solution. That's the idea. We are going to use it. So how do we find that? Suppose your y is taking this one. Y can be written as a product of two terms. Y equal to u. Then what I am going to do, I am going to find what is the solution is going to come. So in this case, y dash is going to become like u dash v plus u v dash, okay, and y double dash is going to become like u double dash v plus I'm going to differentiate this with respect to I'm going to differentiate the second term chain rule, okay, u dash v dash plus here once again u dash v dash is going to come u dash v dash. Therefore, I'm going to put 2 here, and then I'm going to get u v double dash is going to come. Okay. Now I am substituting over here. Therefore, I am going to get u double dash v plus 2 u dash v dash plus u v double dash plus p into, okay, I am going to write px as p only, u dash v plus u v dash plus q u v is going to come equal to 0. Now what I am going to do, I am going to collect the v terms first, okay. So that is going to become like u double dash plus p u dash, okay, here this term, whatever v is coming, that I am going to do. So this one and this one, okay, u double dash p u dash plus q u into v, okay, plus next I am going to collect the v dash term. So v dash term is here and then here, okay. So those two I am going to collect. So that is going to become like 2 u dash plus p u into v dash, okay, plus u v double dash is going to come equal to 0. Okay, so this is going to be there. Fine. Now what we are going to do? Suppose your u is a solution of this one. For example, okay, in this case, suppose your u is going to become a solution of this one. Then what is going to happen? This is going to vanish at this is going to completely vanish. Okay, this will be completely vanishing. So in that case, what we can do? We can do some kind of substitution over here. Okay, so suppose v is a solution. Suppose you found one solution. That's something I have going on, right? Suppose you found u is a solution of that. Then what is going to come? This is going to become like this is completely 0. Therefore, we are going to get u v double dash plus 2 u dash plus p u is going to come. Okay, p u into v dash is going to come equal to 0 is going to come. Now you can substitute w equal to some v dash. Then this equation I can write as u w dash plus 2 u dash plus p u into w is going to come equal to 0. You know that u is a solution, therefore this is known, this is known, this is known. Only W is unknown here. Okay. So now you can solve this problem. So this is going to become like W equal to minus 2U dash plus PU divided by U is going to come. Okay. So this is going to divided by W here. Okay. So this I can write as, this is going to become like ln of W. This side I can write as minus 2U dash by U plus P is going to come, or minus P is going to come. Okay. So again you do the integration. Okay. So this is let's integrate after that. So W dash by W. So if I integrate this one, this is going to become like W is going to come, ln W is going to come, and this is going to become like minus 2 ln U is going to come, and this is going to become like integral PdX is going to come. Okay. So this is the one which we have, and then we can calculate what is my W. So if you take the e power, then this is going to become like you can calculate this one. So once W is known, you substitute over here. Okay, therefore you are going to get B dash. Once again you do the integration, you are going to get the answer for it. Okay, so that's what we are going to do. So here, suppose you have chosen your U. Okay, suppose you have chosen your U. Suppose you chose U such that that's next step. Okay, suppose you chose U such that, okay, 2U dash B dash becomes U, B dash vanishes. Therefore, you are going to get 2U dash plus PU equal to 0 is going to come. So in this case, I can write U dash equal to U dash by U equal to minus P by 2. I can write it. Okay, therefore this is going to become like U is going to become like e power minus P by 2 dx is going to come. Okay. So now we are going to derive the same kind of thing for this one. Okay, for this one we are going to do the same kind of job over here. What I am going to do, okay, next step I am going to find, I am using this one, I am going to find that. So suppose here UV is there, so we have derived this one. Suppose in this one, Y1 is the known solution. Y1 is known to you, then you are going to find the Y2. Okay, Y1 is a known solution, you are going to find the Y2. So in that case, what is it going to come? We are going to derive a similar thing. Y1 be the independent solution. If Y1 is an independent solution, what I have, if I multiply by C into Y1, that is also going to be an independent solution. So that is also going to be a solution. Okay, first of all, constant multiplication is also a solution of that equation. Now suppose you assume that Y2 is a independent solution. Okay, Y2 can be written in this way, CY1. So in that case, it should not be constant. It should not no longer constant. It should be a multiple of. It should be a function of x. Okay, C should be a function of x. Then only I can say that this is going to be independent of x. So if such things are assumed, then we can check whether we can get the second solution or not. So if you assume that C is a function of x instead of constant, and it is twice differentiable, and then we are going to use it over here, and then we are going to find what is the solution is going to be. So let us find that. So let us take y2 is equal to uy1. Okay, y2 is equal to uy1, and then let us derive the same formula. So here it is going to become like u dash. This is going to become like y1. This is going to become like y1 dash, and y double dash is going to become like again u double dash y1. Okay, and this is going to become like y1 dash. Okay, y1 dash, and this is going to become like y1 double dash. Again here, substitute here. Y1 is going to come. Y1 dash is going to come. Y double dash is going to come. Y1 double dash is going to come. Here y1 dash, wherever b is there, replace that with y1. Okay, y1, and then this is going to become like y1. Now substitute over here. Okay, so you can what you can do is that you have u double dash y1 etc. is there. Now what you are going to do is that you are going to collect the y1 double dash term. Okay, y1. Okay, so here we are going to do a little different. What we are going to do is that we are not going to collect this way. Okay, now I am going to collect the u term. Okay, collect the u term here. Okay. Collect the u term. So if I collect the u term, this is going to become like I have u here. This is going to become like y1 double dash. Okay, y1 double dash. The next to y1 is next to u is here. So that is going to become like p y1 dash. Okay, p y1 dash. And here it is going to become like q y1 is going to come. Okay, so this is gone, which is gone, this is gone. Okay, this is gone, this is gone. Remaining thing I have to write. So remaining things is going to become like, this is going to become like u double dash y1 is going to come, u double dash y1 is going to come. Okay, and then here, so this is gone now. Now I have 2 u dash y1 dash. So I'm going to write this as 2 y1 dash u1 dash. Okay, u dash, and then p y1 is going to come. P y1 is going to come. Okay, because I have calculated this. So rest are all. So everything is correct. This is gone. This is gone. Okay, everything is done. Now y1 is already known. y1 is a solution of this one. Therefore, since y1 is a solution, if I substitute here, that is going to satisfy. Therefore, I am going to get y1 double dash plus p y1 dash plus q y1 equal to 0 is going to come. Therefore, this term is going to vanish. Okay. Therefore, what I am going to have? I am going to have this term is going to 0. This is going to become 0. So therefore, what I have, I am going to have here. This can be written as. So I will write here. So what I am going to have? I am going to have u double dash y1, okay, plus 2 u dash 2 y1 dash, okay, 2 y1 dash plus p y1. So this is y1 dash and y1 is here, okay, p y1 into u dash equal to 0 is going. Okay, here y1 is known, here also y1, okay, y1 is known, y1 dash is known, y1 is known. Okay, so therefore what I am going to do, I am going to rewrite this equation as follows. Okay, so I can write this as u double dash, okay, divided by u dash equal to minus 2 y1 dash plus p y1, okay, divided by y1 is going to come. Okay, so I can write that similar kind of things. Okay, what I am going to get, I will erase this. So I am going to get this one. So I am going to use this is going to become like this is going to be minus 2 y1 dash by y1 minus p. That's all. Okay, y1 will cancel. So u double dash by u dash. Therefore, I am going to use this as I am going to substitute. This is something like w. I can substitute, or I have kept v over there. So I will put the same thing. So this is called v. I am going to use v is equal to u dash. Therefore, this is going to become like v dash by v. Okay, I can integrate this one. So if I integrate this one, this is going to become like ln v. This is going to become like minus 2 ln y minus p is going to come. Okay, so if I integrate, this is going to become like p dx. Okay, so therefore what you are going to get, you are going to get this one. Okay, so solve for v, then for u. So this is going to become like d by v. So d of 1 by v, d of y by y1 is given. Okay, y1 here. So therefore we are going to get v is equal to, okay, ln v is equal to minus 2 ln y1 minus p dx plus c star is going to come. Okay, plus some constant also going to come. C star of y. So then what you are going to have, v is going to become, so v is going to become like v is going to become like c into, okay, e power minus px is going to come. This is into y1. So this I can write as, okay, y1 square, okay, y1 square minus is that. Therefore, this is going to come to the denominator y1 square into, okay, y1 square into, okay, this is going to become like e power minus pdx. Okay, e power minus pdx. So I can put some c1. C1 is all. I can put some constant. Okay, c1 into e power minus pdx by y1 square is going to. Okay, so that is nothing but v. Now v is this one. Therefore u is going to become like, okay, so therefore what I'm going to have, I'm going to have my u. U is going to become like this. So u is going to be v dash. Okay, so therefore sorry, u dash is going to be v. That is nothing but 1 by y1 square e power minus pdx. Some constant is there. Okay, some constant I'm keeping. So therefore u is going to become like, I'm going to integrate that again. Therefore c1 into e power minus pdx divided by y1 square into dx is going to come. Okay, so this is nothing but my u. But what I have, y2 I have. Okay, so here one more constant is going to come. Let's say c1 is there, therefore I'm going to c2 here. So I substitute it over here. So therefore y2 is going to become like, y1 into c1 into integral e power minus pdx divided by y1 square dx plus c is going to come. So that means I am going to have, I can write this as c1 y1 integral e power minus pdx divided by y1 square dx plus c y1 is going to come. See, actually I expected, let's say c2 here, so c2 here, c2 here. Actually what I expected is that I want to find the second solution only, but it is coming like general solution itself is coming here because this is going to be this I can take it as y2 and this is going to be a function of y1 is going to be that. Therefore, I can remove this. So y2 is an independent solution if I want, right? That is going to become like y1 integral e power minus p dx dx divided by y1 square. Okay, this is going to be my y2. Actually, I expect only y2 should be found, but I got the general thing. So in that I am going to just take only this comment that I am going to call as y2. Okay, so I can just choose c1 equal to 1 and c2 equal to 0. That is going to give me the y2 solution. Okay, so if you know one solution, let's say y1 is known to you, then this formula is going to give you the second solution, the second linear independent solution that can be calculated by this formula, and this is called Liouville's theorem. Okay.